Welcome back everyone to 6.4. Proving a quadrilateral is a parallelogram. Today, by the end of today, you will be able to understand the relationship between the sides of a parallelogram, understand the relationships between the angles of a parallelogram, understand the relationship between the diagonals of their angles and a parallelogram, and determine if a polygon is indeed a parallelogram. So, back to parallelograms. We did this last lesson in 6.3, and we will do it again today in 6.4. This is going to go a little more in detail. So first off, I want you guys to start with a simple do-now problem. All right, you guys should have finished 6.4. What you should do in this problem, very simple, is you know that opposite sides and opposite angles are indeed congruent. So in this case, AB is congruent to DC, x plus 4 equals 12. You subtract 4 from both sides and you get x equals 8. Angle A is congruent to angle C, so y equals 65. Pretty simple enough for me, right? Problem number B. All right, let's see, is this a parallelogram? Parallel opposite sides, very good. So find FG. FG is across from HE, so those are the two sides that are congruent, and they both equal 8. Angle G is directly across from angle 60, so they're both equal, so it's 60. If I asked you to find H or F, they'd be what? They'd be supplementary, so I'd do 180 minus 60 to find these two. It would both be 120. All right, and there's some algebra in here. First thing to find x, that's an angle because it's on the inside. And angle N equals, or is congruent to angle L. So the two measures are equal. 2x equals 50, divide both sides by 2, and x equals 25. Y plus 3 is congruent to, LM is congruent to NK. So the two side lengths are congruent. Subtract 3 and you get y equals 15. All right. These concepts are what you're going to need to continue on today. We all good? Excellent. So let's finish up with the last part, part B. D is in dog. Which statement is always true about a parallelogram? So let's just walk through it. Can a parallelogram cannot have 4 equal sides? That's not true because all parallelograms have 4 equal sides or congruent sides. So that's true. Which statement is always true? So cannot makes a statement false. Opposite angles are supplementary. No. Opposite angles are what? They're congruent. They're not supplementary. Okay? Now also, a parallelogram can sometimes have 4 equal sides. All right? That's not always though. Sometimes these sides can be different. The two across can be different. All right, so all the diagonals are equal. Are all the diagonals equal? No, only sometimes. So if the sides are equal, and you'll see this in a couple days, and the angles are all 90, then the parallelogram can have equal diagonals. Are all 4 sides parallel? That's a stupid statement. The way the parallel sides work is only opposite sides are parallel. So you have 2 pairs of 2, but not all 4. Because if it was all 4, they'd all be right above each other. Are opposite angles equal? Let's look back here. Oh, of course they are. Opposite angles are always equal. So that's the statement that's always true. Remember, always is different than sometimes. All right, sometimes, maybe sometimes, but always different. All right, so let's do a couple theorems today. Easy ones. If both pairs of opposite lengths of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So let's look. If AB is congruent to, so that deals with the sides. So AB would be congruent to CD, and BC right here would be congruent to, remember to say words, AD, very good. Then this is a parallelogram, all right? If an angle of a quadrilateral is blank to both of its consecutive angles, so if B is blank to C and B is blank to A, then the quadrilateral is a parallelogram. Do you remember this from yesterday? S-U-P, supplementary, very good. That means A plus B has to equal 180, and C plus D also has to equal 180. B plus C equals 180. A plus D equals 180, all right? Pretty much any red and blue added together is 180. Theorem 6.13, if both pairs of opposite blank of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Opposite blank, so angle A and something else. If you said the word angles, you are correct. So angle A would be congruent to angle C because they're opposite. And then angle B would be congruent to angle D because they are opposite. All right, so those are the three basic rules. We went over these before. We're just going to touch up on them again because parallelograms are the most common. So let's look at example 1. We got a nice little basketball rim right here. Hopefully some of you guys will be able to go outside, play some basketball, staying active a little bit. All right, so in the diagram at the right, A, B, and D, C represent an adjustable basketball hoop. Is AD right here always going to be parallel to BC? So that means will it always be a parallelogram? So let's look. The shape of blank ABCD changes. What do you think that is right now? Quadrilateral because it has 4 sides as the adjustment supports move. So as this moves up and down, all these angles change because this moves up, the sides always stay the same, right? But when you move this up, these guys will slide up and this kind of moves back a little bit. When you slide this down, this kind of moves down and like there. All right, so it's, I just gave you the answer. It's angles do not change. All right, side lengths. Oops, duh. Both pairs of opposite blank are congruent. What is shown? The opposite blanks are congruent. Sides, right? So ABC is a parallelogram by which theorem says opposite sides are congruent? Theorem 6.11. All right, I don't really care about going into the theorem so much, but as you can see, since the opposite sides never change, it's always going to be a parallelogram. So by definition, AD has to be parallel to BC because you're doing it. Since it's a parallelogram, then you can show the sides are parallel afterwards. You're using one thing to prove something else. Got it? Awesome. All right, some more theorems. This is a bunch of theorems. If the opposite sides of a quadrilateral are blank and blank, then the quadrilateral is a parallelogram. So if 2 things are true about one set of sides, so what could that be? BC and AD, think of them. So first of all, they have to be congruent. Very good. Now, what else do they always have to be? P, A, parallel. That sounds weird. So they also have to be parallel. So if you just have one set of sides that's congruent and that same set is parallel, that means that, so they're congruent and parallel, this is a parallelogram. Therefore, these 2 sides have to be congruent and these 2 sides have to be parallel. They don't have to be shown to be that, though. It's just assumed. Theorem 6.15. If the diagonals of a quadrilateral blank each other, what can they do to each other? They intersect each other, good. But what else? Where begins the B? Bisect each other. So that means they cut each other in half. So in that case, so if BD and AC bisect each other, okay, meaning B middle, so this piece, and these 2 segments are equal, and these 2 segments are equal. Right? Then it is also a parallelogram. So all you have to do is have these guys equal. And in some cases, all 4 can be equal to each other, but that's okay because it's double bisection. Right? Awesome. Excellent. All right, so why don't you guys try a couple problems? Problems 2 through 5. Good. This is a continuation of yesterday's lesson, so it's very simple. All right, let's look at problem 2. X equals what? 7. Yep, opposite sides are congruent. Y equals 15. Right here. What does A equal? Ooh, so in this case, B equals 119, right? Because B and 119 are equal. How did we find A? We did almost the same slide yesterday. 180 minus 119, so you get 61. And if this is 61, C is also 61. All right. What's T? What's R? R is 19 because these are the 2 that are equal, and T is 16. All right. I know the math here is easy. Just the goal is to get you to get down the concept. Number 5. Let's find X first. How do you find X? Actually, I want to find out what AB equals. So in order to find AB, you have to find out what X is and then plug X back in. What do we know about opposite sides? They are congruent. Subtract 5X, subtract 19, divide by 2, and you get X equals 9. Not your answer, though, because it asks to find AB. Take the 9 and what do? Plug it in for the x right here. 5 times 9 is 45. 45 minus 37 is 45 plus 37 is indeed 82. What would happen if I plugged the 5 in here? You'd also get 82. What happened in here? It wouldn't matter because it's a y, not an x, right? All right, now in order to find y, what do? We equate the two to each other. AD is congruent to BC, so we make the two measurements equal. We subtract 2y from both sides and divide both sides by 2. Y equals 5. So since we're finding a BC right here, 4 times 5 is a simple answer of 20. All right? 2 times 5 is 10. 10 plus 10 is also 20. Got it? Easy, easy stuff. All right. Let's go move on to the next example. Example number 6. Headlights of a car. Ever see a car that has headlights like this? Headlights like this? Maybe. All right, so fancy car. Have the shape as shown. We know. How do you know if angle B and D are congruent? So let's look. In the diagram, this says that BC is parallel to what? AD. Remember when I point, you have to say the answer. And it also says that BC is congruent to what? AD as well. I can't hear you. All right, so just use the theorem names here. This is like writing a proof. Theorem 6.11, that's the one that says if you have two congruent sides, all right, the quadrilateral is a parallelogram, so you have two congruent sides and you have two congruent angles, it's a parallelogram. That's 6.11. So by 6.13, all right, you know that the parallelogram is congruent. So 6.13 says opposite angles are congruent. So that means that angle B has to equal angle D. So we're using 6.11 to prove that this is a parallelogram. Once we know it's a parallelogram, we can use all the other rules. Opposite sides are equal, opposite angles are equal, all right? Opposite sides are parallel, all that fun stuff. So you use the one theorem to prove it's a parallelogram, and then all the other theorems spew out of that one. All right? In a quadrilateral, G, H, J, K, find the measure of angle H is 125. Oops, sorry. And measure of angle J is 55. What is K? So what is K equal to? K is congruent to H, right? So do we need this 55? No. We could just say measure of angle K is 125. And the theorem we're using is opposite angles are congruent. So that is angle K is equal to angle H. Opposite angles are congruent. And that happens to be 6.13. You'll never be quizzed on any of the theorem numbers in this class. I just want you to know what all the theorems mean and how to apply them. All right, all the numbers change based on the books anyway, so it's all obsolete. It's just a good place to go back and look, so that's why they're in the packet. What theorem can you use to show that the quadrilaterals is a parallelogram? What's going on here? The sides are being bisected, right? The diagonals bisect each other. So you go look, which theorem is that? That would be theorem 6.15. All right? You doing good? Excellent, excellent, excellent. All right, let's see, problem 9. To be a parallelogram, name two pairs of sides that have to be parallel. Two pairs means you're going to be naming 4 sides in all. So first set is, did you say, ready, go, XQ and TR. Good. Second set is, louder, XT and QR. Very good. And if you switch the letters here, or the order, it's fine. Ooh, problem 10 looks like a fun one. First thing we're going to do is we're going to find X. Go. All right, now let's go over it. What do you know about these two angles? They are supplementary, so they add up to 180. So 23x plus 17 plus 17x plus 43 equals 180. Combine like terms, 23 and 17 is 40x. Plus 60x equals 180. Subtract 60 from both sides. Divide both sides by 40, you get x equals 3. Yes, we got our x. Now, here's the important thing after you find x. We still need to find y and z. So in order to find y and z, x doesn't help us. We need to know what these actual angles are. So what do we do with that 3? We're going to plug it in for the x. 23 times 3 plus 17. 23 times 3 is 69 plus 17 is 86. Now we can either do 180 minus that to get the answer, or 17 times 3, which is 30, 40, 51, plus 43 is 94. Notice they add up to 180. So Now we can find y and z. So which one of these do you want to use to find y? Hopefully 94. 94 equals 3y. Y equals 31.1. If you use these two, you can also do 3y plus 86 equals 180 and solve it that way, but more steps. And here comes a tough one. Z equals what? 86. Now this is a decimal, not because this actual angle is a decimal, but because 3 times this number gives you 94. That should say 3, by the way. I don't know why it says 1. It should be like 3 repeating. Okay? All right, excellent. All right, it should have said 1/3. All right, so for what value of x is the parallelogram PQRS a parallelogram? So we know one side bisects each other, so what else happens to happen here? We know that both bisect each other. You want both to bisect each other through theorem 6.15, right? So that makes it a parallelogram. So you're given QT. It has to be congruent to what? TS, because of the congruent marks. What do we need to do to find x? What else has to be congruent? PT and TR, right? So now set up and solve. So since the two sides are congruent, the two measurements of the sides, PT, has to equal measurement of TR. PT is 5x, so you substitute in 5x for PT, and 2x plus 9 for TR. You're going to subtract 2x from both sides. 5x minus 2x is 3x. Divide both sides by whatever's next to the variable, which is a 3, and you get x equals 3. Now, since x equals 3, now we can find out, we could check our work. So when x equals 3, it should be a parallelogram. To check our work, we want to make sure that PT equals TR. So we just type in 5 times x, which is 5 times 3. 5 times 3 is 15. RT is 2x plus 9. 2 times 3 plus 9 is 6 plus 9, which is also 15. Since they're equal, we checked our answer. Our answer comes out clear. Our answer is indeed x equals 3. All right, we all good? Awesome, awesome, awesome. Let's go move on. Now, here's the way. I've made a little chart here, and I think this should help everyone very good. So, how to prove a quadrilateral is a parallelogram. So, both pairs of opposite sides are parallel. So, why don't you draw the little symbols there? All right, you should draw arrows. Now, here's the key. I know I messed up on the one problem with it, but since this has single arrows, these have to be doubles. They can't be the same number. Okay, just like with the congruent marks. That means that these are the two that are parallel and these are. Even though you can see it, you want to make sure the problem's drawn better. All right, so number 2, both pairs of opposite sides are congruent. So make your congruent marks. All right, you should have a double, double, single, single. It doesn't matter where you put the doubles and singles. Just say you have one set of 2, one set of 1. Opposite angles are congruent. So draw that. All right. You should draw single and then double. Or you could do single, 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 and then just put the little dash in it, okay, to show that they are equal. One pair of opposite sides are congruent and parallel. Draw that. All right, so it doesn't matter what side set you pick. I picked these ones. You have the congruent mark and you have the parallel mark. If you pick the top and bottom, that is okay as well. Number 4, rule 4. The diagonals bisect each other. All right, it should look something like that, right? And rule number 5, this is the toughest one from yesterday. All right, vertical angles are equal. And then remember, it was the alternate interior angles that were also equal. All right, using these guys here as your transversals. And those are all the rules. You have them in one space now, so if you ever need to go back, you can. All right, so number 14, the figure shows a parallelogram PQRS on a coordinate lane. All right, diagonals SQ and PR intersect at point T. This problem was pulled straight from a NJSLA practice book. So this is some of the stuff they ask you on this stuff there. That's why I threw this in. Find the coordinates of point Q in terms of A, B, and C. This actually is a very simple problem to do. It looks difficult because you have all letters. There's not really any numbers besides the 2 and the zeros. So you have to find out what these coordinates actually are. Now remember, this goes x coordinate, y coordinate, x coordinate, y coordinate. So when doing a problem like this, you know the distance from here to here is 2a. How do you know this? Because it says 2a right here. 2a minus 0 is 2a. Does that make sense? Hopefully it does. Now, we want to find the distance from here to here. What's the distance from here to here? 2b, because this is 2b, that's your x-coordinate. So since this is 2b, this is 2a. Since this piece right here is 2a, that means the top piece here is 2a, right? Since this is 2b, this first one then would be what? What do we do with these two numbers? Segment addition. It'd be 2a plus 2b. Now the height here isn't 0, it's from 0 to 2c, so the height here is 2c. So now we can fill in our whole equation. We got 2b plus 2a, comma, 2c. And that's it. All right? If you want to take away these parentheses, you can. But that's pretty much it. It's not that difficult of a problem. All right? These are numbers. You replace them with numbers. If they're different stuff, different letters, you replace them with different letters. All right. Let's go over the homework. Let's finish the problems. All right, and let's see. Now this 2x plus 3, in case you're wondering, is this piece right here. It's hard to show. And this x plus 7 is that piece right there. So what we know is they're congruent. X plus 3 equals 7 and x equals 4. Got it? Same thing right here. This 5x minus 6 is here. This 4x plus 2 is here. It's hard to put them on inside the equation. She's got to trust me. All right, 5x minus 6 equals 4x plus 2. 4x subtracted from 5x is x minus 6 equals 2. X equals 8. Problem 3. This one's a little bit better to see. Those two have to be bisected. 3x equals 2 and x equals 2/3 or 0.67. All right, what's x equal here? That's 66. It equals 180 minus 66. 180 minus 6 is 114 because they're supplementary. Right here, 2x plus x equals 180. 3x is 180 and x is 60. All right, these two, supplementary. All right, x plus 10 plus 2x plus 20 equals 180 again. X and 2x is 3x, plus 30 equals 180. 3x equals 150, and x equals 50. All right? Hello. All right, so are these figures parallelograms? You can use your SSS, SAS, all the theorems we used before. So, in this theorem right here, do you remember what theorem we can use? Side, angle, and then BD is the side that we already have, so that's side, angle, side. So in this case, we got these two triangles are congruent, meaning these two, AB and DC, have to be congruent. So then you got opposite sides congruent, all right, because of the side, angle, side. All right, right here, because if these two triangles are congruent, everything's congruent. We got angle, angle, angle. You did that on purpose. Or we have angle, side, angle. So yes, it is congruent. ASA. So as soon as these two triangles are congruent, it means these two are congruent and these two are congruent. All right, and since they're congruent, opposite sides, you have a parallelogram. This one right here, what do you think? Well, these two angles are congruent and it's congruent to this one. So that means that this angle has to be supplementary to this. So this angle is also supplementary to that angle, which is also supplementary to that angle, right? Consecutive angles are supplementary. So since this is supplementary, this angle has to be equal, so opposite angles are equal. Well, and that's it. Tricky, but easy. All right, so that concludes the lesson today. Tomorrow, let's see what we do. Rectangle, square, and rhombi, I believe. But for now, hopefully you're getting everything. If you have any questions, please email me and continue on with the good work. Everyone's doing an excellent job, and I am glad to see all your stuff you're doing. All right, so keep working on those packets, and see you soon.